Here we're going to do some chain rule examples that all involve inverse trig functions. Let's start with finding the derivative with respect to x of arccosine of 5x squared. So we have a composition, we know it's going to be a chain rule. Let's first remember the derivative of arccosine of x. That's going to be -1 over the square root of 1 minus x squared. So we have 5x squared on the inside. So when we take the derivative of arccosine x, we're going to replace that x with 5x squared. So it's going to look like -1 over the square root of 1 minus, and again, in place of that x, we're going to put our inside function 5x squared. So we've done the derivative of the outside while leaving the inside function the same, and then times the derivative of that inside function. So the derivative of 5x squared is 10x. And to simplify, we can multiply the 10x times that -1. So we'll have -10x all over the square root of 1 minus 25x to the 4th. If we go ahead and take 5 squared and x squared squared. Now let's find the derivative with respect to t of sine inverse of tangent of 3t. So here we have actually two compositions. So we have 3t inside of the tangent function and tangent of 3t inside of sine inverse. So we're always going to work with that outside function first. So let's remind ourselves that the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. So in place of x, we have this entire function. We have tangent of 3t. So that is what's going to replace the x in the derivative, 1 over the square root of 1 minus x squared. So we're going to have 1 over the square root of 1 minus tangent of 3t all squared. So what we've done so far is the derivative of sine inverse, leaving that inside function the same. So that layer is done. And now we need to do the derivative of the inside function. Well, that is its own chain rule. And the outside function there is tangent. So the derivative of tangent is secant squared. But we have to leave the inside alone. So secant squared of 3t. So we've peeled off the next layer. We've now done the derivative of tangent, but we have to do the derivative of the final inside. The derivative of 3t is 3. All right, so this is our derivative. We just can put it together now with a numerator of 3 secant squared of 3t all over the square root of 1 minus tangent squared of 3t. So here, when there's a nested composition and we need to use the chain rule multiple times, we can use the analogy of an onion, peeling off the layers of an onion, so working on the outside until we get to that final inside derivative. Sometimes people think about Russian nesting dolls. Whatever it takes to not forget to continue to differentiate from the outside in if we have this nested composition. Now let's find the derivative with respect to x of x times arctangent of x cubed. So here we're actually going to need to use both a chain rule and a product rule. Sometimes students get confused about what rule to use and when. It really helps to say it out loud. So here notice that I said x times arctangent of x cubed. So when I have a function of x times a function of x, so see how there's two variables. So a function of x and then arctangent of x cubed. So we have a product, but a composition because I use that word of, arctangent of x cubed. So this arctangent of x cubed is a composition. This is not a product. The product is the x times arctangent of x cubed. So we're going to start with the product rule. And we're going to say that we have the first function, we'll leave one of them alone. So I'm going to leave that first function alone, x, and then times the derivative of arctangent of x cubed. Now that's going to require a chain rule. Let's remind ourselves the derivative of arctangent of x is 1 over 1 plus x squared. In place of our x is x cubed, So we're going to replace our x with x cubed here. So we're going to have 1 over 1 plus x cubed squared. Now all we've done is the derivative of arctangent, leaving the inside the same. We need to multiply by the derivative of the inside. So the derivative of this x cubed is 3x squared. So we need to multiply by 3x squared. Well, hopefully you recognize that it's really just multiplying that numerator by 3x squared, which is just 1. So actually it's going to be just a 3x squared up in that numerator. So we have, so far, we've left one function alone, the derivative of the second function, which required a chain rule. Then we return to that product rule plus the second function, arctangent of x cubed, times the derivative of that first function, x, which is just 1. So all I'm going to do to simplify this here is multiply the x times the 3x squared. So that's going to leave me with 3x cubed over 1 plus x to the 6th. We'd multiply these exponents, and then plus arctangent of x cubed. Let's just take a brief moment to recap the chain rule with inverse trig functions. So if we have the derivative with respect to x of sine inverse of f of x, that ends up looking like f prime of x, the derivative of the inside, over the square root of 1 minus f of x squared. I don't want us to think about this as a whole new derivative. We should already know the derivative of sine inverse of x is 1 over the square root of 1 minus x squared. So the only difference is, again, replacing the x with f of x, and then we multiply by the derivative of that inside function, which is essentially just multiplying that 1 on the top by the derivative. So again, if we already know the derivatives of sine inverse or arcsine, those are just alternate notations of the same thing, we are just applying the chain rule to those. They just look kind of a little bit different. So sometimes students struggle with these at first until they realize it really is just the chain rule.